Okay, so I'll be doing question number 25. And so first, let's start with A. So for M1, say this is M1, it would have a force downwards because of Earth. So a force downwards. And then a force upwards from string 1. String 1. And that'll be M1, M2. Nope. M2. Again, upwards force of from S1. F. And then it has gravity as well, so F of E. And because S2 is also pulling down at the force of S2. And then you have mass 3, which has a force upwards from string 2, as seen here. Oops. F of S2, and then the force downwards from Earth. Now, right now that these aren't like what they're supposed to be yet. For example, this length should be a lot longer, and these should be a bit shorter. Right, then, so for B, we have to find the acceleration. So first, I label out the masses. So what we want to do is first calculate the sum of the forces. So the sum of the forces is equal to the force that's pulling down on M1. So I'm just going to label these as minus, plus, and then minus, and plus. So there's a force, there's gravity acting on M1, and there's also gravity acting on M2, as well as M3. Right, so we got that. So now we have that. And so basically, so obviously this is going to be negative. So say, I'm just going to, one sec. Right. So sum of the forces is F of Earth on M1, F of Earth on M, plus F of Earth on M2, plus F of Earth on M3. However, I'm just going to abbreviate them to be F of 1, F of, that was horrible, F of 2, and F of 3. Okay, so from here on, we just have to find F of 1, which is, so F of 1 equals M times G. Now in this instance, if the G is going to be negative 9.8 meters per second squared, so equals 10 kg times, let's go again, times negative 9.8, that's horrible, meters per second squared. And that would give me negative 98 newtons. So that's F1. Then moving on to F of 2, it would equal M1 M2 times G. Now in this instance, the G is going to be positive, so equals 5 kilograms times 9.8 meters per second squared. Almost fit down. Okay, which is equal to 49 newtons. Now then, for F of 3, it would equal mass of 3 multiplied by gravity. Again, this is positive, this thing, which is equal to 7 kilograms times, again, 9.8 meters per second squared, which is equal to, one sec, this is annoying, which is equal, this is equal to 68.6 newtons. Now then, coming back to this, the sum of the forces would be equal to negative 998 newtons plus 49 newtons plus 68.6 newtons, which is equal to 19.6 newtons. And now you can go, well, I'm gonna move over here. You can use Newton's second law. So the unbalanced force, aka the sum of the forces, divided by the total mass of the system. So sum of the masses equals acceleration. And to substitute all the values in, it would be 19.6 newtons divided by 10 plus 5 plus 7 kilograms, which is equal to 22 kilograms. So 19.6 newtons over 22 kilograms equals 8. One sec, I'll get my calculator. So A, after getting my calculator, so A equals 0.8908. Nope. Oops. 09 dot dot dot. And which can be abbreviated into 0.891 meters per second squared. Oh, get that second. Okay. And there you have it. Okay, so now I have a new particle screen to use. I think it's this one. Yeah, that's this one. Okay, give me a sec. And it's this one instead. So now let's see. This is probably where most people got the question wrong. So it's asking for the tension, which is basically, well, we can draw a free body diagram, which is basically a force diagram involving multiple objects. So say this is M2 and this is M3, and between them is S2. So M2 has some force pulling upwards due to S1, and M3 has some force pulling downwards because of, well, that was horrible, because of gravity. Okay. I'm just getting these things wrong the entire time. Anyways, so this is basically tension. You can see it as the force that's being exerted on the string, I guess, kind of. So the string is pulling, well, it's pulling up on M3. If you look at M3's force diagram, you can see that. And M3 F, oh no, right. So right, this, we're basically seeing, this force is basically what we're trying to get. So the total force downwards is M3 times gravity, which is 7 kg times 9.8 meters per second squared. Again, pardon my handwriting. Which is equal to 68.6 newtons. However, it's not falling down at this pace. The speed, if I remember correctly, was So let's see. So the A equals F over M, and A equals 0.891 meters per second squared. The F is basically what I see as like the amount of energy from this part that's being used. So it's equal to F, actually sum of F, since it's this force plus this force. Remember, negative, positive. So sum of F over M. Oh, not over M. Well, M3, which is equal to 7 kg. So give me a sec. I have a calculator. Okay, so it's 6.237 newtons, which is equal to the sum of F. Moving over a bit. And now a bit bigger. I wasn't down very much, but anyways, so the sum of the sum of F can be seen as is equal to F of Earth on and 3 plus the F of string 2 on mass 3. So 6.237 newtons is equal to 68.6 newtons plus force of, well actually in this case it should be minus, so one sec. I'll erase this. Not very efficient, but hey, it works. And I'm just using this to get a positive force value because, well, tension, it would make more sense for it to be negative since it is a rope that's being pulled. So okay, you didn't see that. Okay, F of S2 on I'm messing up all over the place today, aren't I? Actually, you know, it does somewhat make sense that it's negative. So why not? Why not? Okay, give me another sec. So from this I can get that F of S2 on M3 is equal to negative 62.363 newtons, and that comes out to be the tension. And I suppose it does make sense because if it was positive tension, then I guess it would be compressing instead of being pulled apart. So yeah, there you have it. That's the tension. And thank you for listening. This was quite a long screencast, I understand, but if you took the time out of your day to hear this, then thank you. Goodbye. Okay, never mind that. So apparently I checked online and tension cannot, well, like, if it was negative tension then it would be compressing, so get rid of this. And that's what the equation of tension appears to be, this, I guess. Appears to be like the force that's acting downwards minus tension equals the sum of the forces. So yeah, I mean I may have under. Sorry about that. But here I think everything should be correct. I hope at least. If anything is wrong, please tell me. And thank you very much.